All right, so I think I'm recording now. Uh, let's take a look at we're looking at skill packet 3 and is specifically we're looking at the building functions with new functions with two old functions and finding the domain of this new function. And I want to do some examples to where we're finding the domain. Given a function f and given a function g, we're going to find the domain of this new function fg, this new function f divided by g, and this new function g divided by f. And I don't have to find the actual equation for the functions themselves. I can just use the domain of f and the domain of g and information about f and g to give these answers. So I know that when they ask me to find the domain of g, if I call this part A, that the domain of this new function fg is always going to be the domain of f intersected with the domain of g. This symbol is the intersection of two sets, and we read it as and, the domain of f and the domain of g, meaning that if you're the members of the domain of f have to and also have to those members have to be in the domain of g, they have to be elements of both sets to be in the intersection. And in B, the domain of f over g, again, it uses the same, well, it won't let me copy it. I use part of my previous answer, but I also need to be aware that I now have a function in the denominator that may have, for some value of x, may have a value of 0, and I can't let that happen. I can't divide by the number 0. And then the last thing we're going to do is find the domain of a new function where we take the old functions and divide them, g over f, where again I have the domain of f intersected with the domain of g, and then I intersect that. I'm concerned about any values that would give me 0 in the denominator, and I need to exclude those values. And this time my function in the denominator is f. So this is how we're going to approach each one of these problems. So let's do the first one. So we have f is given as the square root of x plus 3. G is given as x squared. Let's find the domain of f. Okay, so to find the domain of f, we always start out given an equation to find the domains the same way. The domain is a set of all real numbers, but it has some possible restrictions. It's a set of all real numbers excluding any values of x that cause division by 0. I do not have any variables in the denominator, so I don't have to exclude any values. So right now I'm thinking, hey, my domain is all real numbers. But I also have to be afraid of taking the square root of a negative number. And I do have a variable that's underneath a radical. So this x plus 3, it can equal 0 because I can take the square root of 0 and I can take the square root of a positive number. What it can't be negative. This x plus 3 cannot be less than 0. So the values of x that I can have as my input, the values of x that I can plug into this function in order to get an output, and in fact it'll be exactly one output for this function, are values of x that are bigger than or equal to negative 3. So if we write that in interval notation, we've got negative 3 greater than 0 because, let's draw a picture here, negative 4 is smaller than negative 3, it's to the left. Negative 2 is bigger, it's to the right. I'm going to shade in my point at negative 3 because of the equality. It's okay for x to be negative 3 because I get the 0 and I can take the square root of 0. And I want values that are larger than negative 3. Okay, so there's a picture for my domain of f. Now let's find the domain of g. Well, the domain of g, I don't have any variables in the denominator, and I don't have any square roots. So remember, the domain is a set of all real numbers, excluding any values that cause division by 0. Hey, I don't have to exclude anything there. And then also excluding any values that cause us to take the square root of a negative number. I don't have to exclude anything there. My domain for g is all real numbers. Okay, so let's draw that picture, and we'll draw it right below our picture for the domain of f. So let's label that. This picture, this graph was for the domain of f, and this number line, this graph, is for the domain of g, and it's all real numbers. The whole thing is shaded. All right, so I know that the domain of f times g, if I draw a picture of its answer, is going to be the intersection of these two sets. You have to be a member of the set that's the domain of f, and you also have to be in the domain of g. So it's the domain of f intersected with the domain of g. So this negative 3 is shaded in both, because right here, say, is negative 3. But to the left of negative 3 is not shaded in f, so it can't be shaded in both, and it won't be shaded in my intersection. To the right of negative 3 is shaded in the domain of f, it's shaded in the domain of g, it's going to be shaded in my answer. So this domain of g did not add any new restriction nor change the restriction of the domain of f, so the domain of this product, f times g, is the same as the domain of f, and that's negative 3 to infinity. Now that's not going to happen with every problem, but it did happen for this problem. All right, so let's continue. All right, so let's erase this and this. All right, so now in part B, I'm trying to find the domain of f over g. Okay, so I'm going to use the domain of f, I'm going to use the domain of g, but I have to also be afraid that this g that's in a denominator could equal 0. I need to prevent that from happening. I need to make sure that I'm only using values of x that prevent g of x from being 0. Alright, so what is g of x? Well, g of x was this x squared. So if I temporarily set it equal to 0 and solve that so I know what to avoid, well, I take the square root of both sides and I can see that x equals 0. And remember, we're trying to avoid that from happening. We do not want this g of x to equal 0, so I do not want x to be 0. So let's come over here and include that. Here's negative 3, and 0 is to the right of negative 3. Now, that's the only value I'm excluding on this number line. It's the only value that caused division by 0, that caused this g to equal 0, and g's in the denominator. So this was the values that prevent g from being 0. So if we draw a picture of all three of these, we had a point of interest negative 3, and we have a point of interest 0. And negative 3 is shaded in all three of these sets in this intersection. And 0 is not shaded in this one. It has to be shaded in all three to be shaded in my answer. To the left of negative 3 is not shaded here. It has to be shaded in all three to be in my answer. Now between negative 3 and 0 is shaded in all three, so it's shaded in my answer. And to the right of 0 is shaded in all three. So my domain for f over g is the set of all real numbers that are greater than or equal to negative 3, excluding 0, however. All right. And now let's do this last one. So let's erase this part that was in green, and we want to now find the domain of g over f. So now our denominator is f, and we do not want any values of x that causes f to be 0 because we can't divide by 0. So we have the domain of f intersected with the domain of g, and now intersected with all of the values, and I said f, not g, all of the values of f that do not make this function 0. So let's take a look at f. Square root of x plus 3. If that were allowed to equal 0, I'd be in trouble because f is in the denominator. I want to prevent this from happening if I square both sides of the equation, if I subtract 3 from each side. If x is equal to negative 3, then this f is equal to 0. I don't want that to happen. So I'm going to throw out the number negative 3. So if I come over and make a sketch of that, at negative 3, it's not in the set. To be in the set of my intersection, you have to be shaded in all 3 sets. This one, and this one, and this one. So this negative 3, before when I had just 2 sets, it was shaded in both. But now with this additional set, it's not shaded in there. So negative 3 is not going to be shaded in my answer. It's not shaded to the left of negative 3 here. It is everywhere else, but since it's not shaded here, it's not shaded in my answer because it has to be in all 3 to be shaded in my answer. To the right of negative 3 is shaded, to the right of negative 3 is shaded, and to the right of negative 3 is shaded. This part is shaded in all 3, so it's shaded in my answer. So the domain of g over f was real similar to the domain of f times g. It's just that in f times g we included negative 3, but now we're excluding negative 3. Alright, so there's our 3 answers for this first problem. And just double check that yeah, alright, and I'll do the next one on another video. So I hope that helps, and I'll talk to you later.